Welcome back, science students. Today we're going to be talking about the different types of chemical reactions. For our purposes, there are four main types of chemical reaction. Let's start off with taking a look at the first type of chemical reaction, a synthesis reaction. Okay, so our first type of reaction is a synthesis reaction. In a synthesis reaction, what we have are always two single elements or small compounds and that are going to join together to form one single product. Now, the general equation for a synthesis reaction is A plus B reacts to produce AB, where A and B are elements or small compounds, and we have one compound in the products. And that's the easiest way to spot a synthesis reaction, is that there's only going to be one thing in the products. Now, here's an example. We have aluminum and chlorine gas reacting to produce aluminum chloride, one compound in the products, formed from two single elements here. We are going to use the analogy of a marriage for a synthesis reaction, because like a marriage, we have two single individuals coming together to form one single unit. Very romantic. And unfortunately, it all goes downhill from here. Let's take a look at our next type, decomposition reactions. Okay, our next type of reaction is a decomposition reaction. In a decomposition reaction, what we start off with is one single compound that is going to decompose or break down into two or more pieces. Now, the general equation for a decomposition reaction is this. AB reacts to produce A plus B, where AB is a compound, and that's the easiest way to spot it, is there's only ever going to be one reactant, and that reactant is going to break down into two or more pieces. They could be elements typically, but they may also be small compounds. Here's an example of this, and this is one you should be familiar with, the electrolysis of water, where we're going to just start off with water. So one reactant must mean it's a decomposition reaction, and it's going to split down into, or decompose into, H2 plus O2, hydrogen gas and oxygen gas. Now in a synthesis reaction, we use the analogy of a marriage, where we had two individuals becoming one. What do you think we use here? Well, that's right, we are going to call this the divorce. We have one couple happy until something goes wrong and finally splitting up and going their separate ways. Okay, so decomposition, the divorce. Okay, our next type of reaction is the single displacement reaction. Now, for a single displacement reaction, what we're going to start off with is we're always going to start with a single element and a compound. That's what we're going to find in the reactants, and that's actually what we're going to find in the products as well, a compound and one single element. Now, let's take a look at the general form of our equation here. Now, for this one, there's two general forms because it depends on what the single element in the reactants is. Is it a metal or is it a non-metal? If it's a non-metal, we're going to see this, where we have AB plus Z, where Z is a non-metal. So we have one compound, one single element. This single non-metal is going to come in and kick off the non-metal, in this case the B, in the compound. So what it's going to do is it's going to displace the B, and the B will be all by itself. Now, if instead it's a metal in the reactants as a single element, what's going to happen? It's going to come in, it's going to displace or kick off the metal. So in this case, the X is going to come in and replace the A, and we're going to get XB plus A. Okay, let's take a look at an actual example here. Here we have chlorine gas and sodium bromide. And what's going to happen? Chlorine, is that a metal or a non-metal? It's a non-metal, very good. It's going to come in and it's going to kick off the non-metal in the compound, which would be the bromine. So it's going to come in and replace, and we're going to have sodium now with chlorine and bromine all by itself. Now for an analogy for this one, we are going to call this the affair. And this is where things get a little spicy. Sodium and bromine happy forever together. Well, that's until chlorine comes along, tempts sodium away, steals it, and sodium and chlorine are now together and pour bromine off by itself. So this is the affair. Our last type of reaction is what we're going to call a double displacement reaction. In a double displacement reaction, what we start with are two compounds in the reactants, and we end up with two compounds in the products. So that's how we're going to spot them. Two compounds in the reactants, two compounds in the products. The general equation is AB plus XY produces AY and XB. So AB is a compound with a metal and a non-metal, XY is a compound with a metal and a non-metal, and what's going to happen is they're going to trade their partners. The two non-metals are going to switch spots. So the Y, which is the nonmetal in this compound, will come over and join the A, which was the metal in the first one. And then the X, which is the metal in the second one, will partner up with the nonmetal from the first compound here at XB. Let's take a look at an example of this. Here we have HCl, hydrochloric acid, combining or reacting with iron 2 sulfide. And what's going to happen, the metal here is going to take the nonmetal from the first compound, and the hydrogen, which is acting like a metal here, is going to partner up with the sulfur from the other compound. So we're going to end up with FeCl2 and H2S. Now our analogy for this one, this is where it really gets spicy. This is the spouse swap. And what we're going to have is the two partners trading places. This is kind of like that TV show Wife Swap. It didn't last too long, but very similar thing going on here. All right, that's the double displacement reaction that you spot by looking for two compounds in the reactants and in the products. Okay, here we have 4 different reactions. Your job is to try to classify it as one of the 4 types we've looked at: synthesis, decomposition, single displacement, double displacement. Pause the video now, try to identify them, and then start it up again and we'll see if you got these right. Okay, so the first one, here we have potassium chloride becoming potassium chloride and oxygen gas. Which type of reaction did you think it was? Hopefully you said decomposition. The thing that tells me right away that this is a decomposition reaction is that we only have one reactant, and it's a compound. Okay, one reactant, and it's being broken down here into a compound and an element. So decomposition reaction. In the second one, here we have iron plus copper 2 sulfate becoming iron 2 sulfate and copper. Now, the thing that tells me that this is a single displacement reaction is I have an element and a compound in the reactants and a compound and an element in the products. So as soon as we have an element and a compound, we know it's going to be a single displacement reaction. In this case, iron's a metal. It's going to come in and kick off the copper, which is the metal in that compound, replace it, and we're going to have FeSO4, and copper will be all by itself. This next one, here we have phosphorus and chlorine gas becoming phosphorus trichloride. In this one, the thing that tells me it's a synthesis reaction is we only have one compound in the product. As soon as there's only one compound, we know it's a synthesis reaction because those two have become one. This is the marriage. In the last one, here we have sodium chloride plus silver nitrate becoming sodium nitrate and silver chloride. Now, what tells me right away, and people are pretty good at this normally, is seeing the two compounds becoming two different compounds. So this has got to be a double displacement reaction. Hopefully you got those, and if not, hopefully you see now why they are the way they are. All right, let's see what else we can do with this newfound knowledge. Okay, now what we're going to do is we're going to put our newfound knowledge to the test and see if we can use what we know to identify the type of reaction used looking only at the reactants, and then use that information to predict what the products of the reaction are going to be. This is pretty powerful stuff. So in this first one, what do I have? I have magnesium and aluminum nitride. Now, what is that? I have an element and a compound. So if I have an element and a compound, which type of reaction must it be? Well, it's got to be a single displacement reaction. In this, I have magnesium, which is a metal. It is going to take the spot of aluminum, which is the metal in the compound. So my new compound is going to be Mg combining with nitrogen. Now what I need to do here is I've got to be careful. I've got to come in and figure out what that compound's formula is going to be. So I can't forget all that stuff we've learned in the first half of our unit. So what I have to do is maybe off to the side, I'll go Mg plus 2, nitrogen minus 3, crisscross, 3 comes down, 2 comes down, Mg, 3, and 2. So I can't forget all that stuff. Then, what do I need? Well, aluminum just off by itself, and since it's a metal, we just write it by itself, Al. Okay? So we are able to predict that it's going to be magnesium nitride and aluminum. In the second one, here I have sodium and chlorine gas. What is the reactant, or what type of reaction do we have? Well, I have an element and an element, so 2 single elements. What's going to happen? Well, it's a synthesis reaction. We are going to see our marriage and these 2 elements becoming 1. So what do I have? I've got sodium and chlorine, and off to the side I'm going to go Na plus 1, chlorine minus 1, crisscross, crisscross, NaCl. Then, in the next one, here I have sodium fluoride and chlorine as well. We're generally working with some easier numbers to work with. So, I have a compound and a single element. Which type of reaction is this? Well, compound and element, it's got to be a single displacement reaction again. This time, I've got chlorine, which is a nonmetal. So what's it going to take the spot of? Is it going to take the spot of sodium or fluorine? Well, it's going to take the spot of fluorine because it's a nonmetal. So I'm going to have sodium and chlorine. Once again, we're going to get sodium chloride, +1, -1, crisscross. And then we're going to have fluorine all by itself. Now, when we write a nonmetal by itself, typically what you're going to want to do is put F2 because it'll become fluorine gas. All right, in this next one, here I have magnesium chloride and iron 2 sulfide. For this one, I have a compound and a compound. Whenever I have two compounds in the reactants, what type of reaction must it be? Well, it must be a double displacement reaction. So in this one, the metal from the first compound is going to join up with the nonmetal from the second one. So magnesium and sulfur. And off to the side, I'm going to go Mg +2, sulfur -2, crisscross, 2 coming down, 2 coming down, Mg2, S2, but realizing that I need to reduce that down to MgS. So that worked out quite nice. Then, my other compound, I'm going to take the iron, which was iron 2, and I can tell that just the way that compound is with chlorine. So off to the side, Fe +2, chlorine -1. I'm going to crisscross FeCl2. And there we go. So once again, we're able to predict the products of that reaction just by knowing the type of reaction it is. Last one. Here we have HGO. Well, there's only one reactant, so it must be a decomposition reaction. So what we're going to see is the mercury and the oxygen separating, and we're going to be left with mercury by itself and oxygen by itself. And since oxygen is a nonmetal, we're going to write it as O2. So there we go. Just by knowing the types, we're able to predict the products. Pretty powerful stuff.